Here I am on my kitchen floor to bring you a theoretical math problem of about the Algebra 2 level. Now I threw down these three discs that I cut out earlier, wanting to know whether or not they would cross one of these lines when I threw them down. Now clearly the probability of whether they're going to cross is a function of how big they are relative to the size of this grid. So my question is, if you're throwing a disc onto a grid like I just did here, and you know how long these distances are, how big does the radius of the disc have to be so that when you throw it down, the probability of it crossing one of these lines is 50%. So you can see how this goes. The probability of it touching one of the lines when it lands is clearly a function of how big it is to begin with. So if you're throwing down like little holes from a hole puncher, odds are very few of them are going to come in contact with one of these lines because they're so darn small. But if you take something that's a lot larger and drop it down, it won't always hit, but it's likely that it's more likely that it's going to hit one of the lines than if you drop something really small like a piece of confetti. So the problem is, what does the radius have to be relative to this length as a percentage of this length? Say 20%, 30%, I don't know what it is, but what does the radius of the disc have to be relative to the length of the side of one of these squares, so that when you throw it down, the probability of it crossing one of the lines is 50%. Now this is really cool too, because once you get the answer theoretically using the algebra, you could confirm it experimentally by taking your solution, cutting out circles of the size that you got, and throwing them onto the grid that you were doing your calculations from to see how many of them cross. And if you got the answer correct, about half of them should cross lines and about half of them shouldn't if you do it over and over and over again. For a bonus problem, figure out what the radius has to be as a function of this length for an arbitrary probability. So how big does the radius have to be relative to this length if you want the probability to be 10%, or if you want the probability to be 85%, or p%? That's the added problem. And I'll do the answers in an upcoming video. Thanks for watching.